Hi, AP Stats. We are going to take some notes on the rest of 9.2. So let's first talk about what significance level do I pick. And we've talked about this a few times, but we know the three main significance levels are 0.01, 0.05, and 0.1. So 1%, 5%, and 10%. And generally, in a free response, I'm so sorry, they're not going to tell you. So we're going to assume 5%. That's like just the typical AP answer. However, if you were out as a real statistician running a significance test, you would decide your significance level based on which error you want to avoid. So you would have to consider which error, type 1 or type 2, is worse for your company, worse for your client, worse for whatever. And that would be the one you would want to avoid. So if you remember, the probability of a type 1 error is linked to the significance level. So if I want to avoid a type 1 error, I will make a significance level of 0.01. If I want to avoid a type 2 error, I have to increase my significance level, so I would pick a 10% significance level. As I just said, in a free response, you're not going to have to decide necessarily which significance level. I would just say 5%. However, there could be a follow-up problem or a question embedded in a free response that says the consumer wants to avoid this kind of mistake. What significance level should they pick? That would be the type of problem I could see you having. Then the question is, how are confidence intervals, everything we did in Chapter 8, how are those related to significance tests? So let's take a moment to just remind ourselves what a confidence interval is. A confidence interval creates an interval of plausible parameters. Remember, parameter means a number that comes from a population, so mu or p. And a significance test, what we've been looking at the past week or so, assesses evidence against a claim. So how are these two related? Because guess what? They are very much related. If I have some C% confidence interval, that will give me the same result as a 1 minus C% significance level significance test. So if I have a 95% confidence interval, I would pick a 0.05 significance level, and those two inference methods, while they wouldn't give you the same answer, right? A confidence interval actually gives you an interval. A significance test just says we reject or fail to reject, but they would give the same conclusion, which I'll show you in a moment. So one thing we could say is a confidence interval, a C% confidence interval, gives us an interval of null hypotheses that would not be rejected by a two-sided significance test. Meaning a confidence interval is going to give you an interval of values. It'll say 0.2 to 0.4, 20% to 40% of the population believe in ghosts, whatever. And any number in here, if that was our null hypothesis, if our null hypothesis is that p is equal to 24, then we would not reject that. We would fail to reject that. We would say we think this is true because it comes in our interval. Let's look at our last example in a different light. Find and interpret a confidence interval for the true proportion of expenses that begin with the digit 1 for the company in the previous example, and then should your company be investigated for fraud. Now, we technically know the answer to B. When we did this problem in class, we said yes, this company should be investigated. However, we are going to see that this answer for B is the same whether we do a significance test or a confidence interval. So for A, find and interpret a confidence interval for the true proportion. Maybe you have to flip back, and that's okay, but I know this is going to be a 1 sample Z interval. 1 sample Z interval. And I will say, and I forgot this 20 seconds ago, we're not going to do a full state plan, do, and conclude here. We are just going to find and interpret the interval. So 1 sample Z interval, P hat plus or minus Z star times the standard deviation of our sampling distribution of sample proportions. Actually, it's a standard error, but P hat times 1 minus P hat all over N. And maybe we have to flip back to remind ourselves, but what were our pieces in this puzzle? P hat was that 68 out of 300. Our sample size then is 300. And in the last example, we ran a significance test with an alpha equals 0.05 significance level. So they don't tell us what confidence level to choose here, but because we said our significance level is 0.05, that means I am going to choose a 95% confidence interval. So I need to find my critical value, Z star, and I'm going to use my calculator. I don't have the calculator on my laptop, I apologize, but you're going to be going to inverse norm. We are looking at area, mean, standard deviation. If we want the value to give me 95% in between, that means this lower is 2.5%, or I could type in 97.5% as well, whichever one makes more sense to you. 0.025, a mean of 0, and a standard deviation of 1. If you want to pause the video to get this, otherwise, this would be 1.96 as our critical value, which we've seen a lot of times as we've done our 95% confidence levels, so it shouldn't be shocking. All right, so we have all of our pieces. 68 over 300 plus or minus 1.96 times the quantity, square root of that 68 over 300 times 1 minus 68 over 300, all over 300. And yes, of course, you can use your graphing calculator to calculate this interval. If you want to pause your video to either do it in your calculator or type that all in, that would be great. Otherwise, the interval I calculated is 0.18 to 0.27. So that's our interval. Now we need to interpret it. We are 95% confident that an interval from 18% to 27% captures the true proportion of expenses that begin with a 1. All right, so that's A. We calculated the interval, we interpreted it. B says, should the company be investigated for fraud? And if you remember, they said, if there is no fraud, the true proportion is 0.301. The interval we got is 0.18 to 0.27. And this question has been asked a lot. Does this value make sense with our interval? Well, no. Look at how our entire interval is below that number. If there was no fraud, we would expect the true proportion to be about 30. We would expect that true proportion to be in our interval. but it's not in our interval. 0.301 is not in our interval. So we should investigate further. And like I said, we already knew that, right? We did the significance test. The only reason we're doing this example is to see that you're going to get the same conclusion, even though it is a little bit, you're not quite going to get the same information, right? In a significance test, we don't necessarily get an interval of values, but that's okay. Last thing in this chapter is how would we decide what inference method to choose? And I'm going to give you two answers. The first answer is if it is a one-sided alternate hypothesis, so that means greater than a number or less than a number, you are going to use a significance test. If it is a two-sided alternate hypothesis, meaning not equal to, it's actually better to use a confidence interval. Because like we saw in the last example, we were given more information. It wasn't just that the value was not equal to 0.3, it was that our interval suggested it's less than 0.3. Now, the other answer to this question, though, is for which inference method should I use? Read the problem, right? And figure out what they're asking. A lot of times there will be language in it that helps you discern which method to use. If it's investigating a claim, they might use that word. If they want you to show that there's convincing evidence, that would mean significance test as well. If they give you a confidence level, that's going to mean confidence interval. We'll go through more of this as we continue this semester, but you technically now have two different choices for inference methods. All right, have a great rest of your day.